Well, this is video for our customer JP, who sent us a Y main board for HBT5054 along with two sets of buffer boards, his original one, both of which have pretty badly failed, and a set of boards that he bought elsewhere that were marked good, like this one, and this is the bottom one from the same JP. The Y main was pretty badly burned and the two buffer boards were burned, so we recommended replacement. We bench tested the buffer boards and they were fine, and that's what we reported to the customer, and he chose to get a replacement Y main board along with a video showing how they work in a TV. I just put them in, and upon trying to test them like a minute ago, I saw the usual display deformations right as soon as the VS gets sent and the data stream starts failing. I have a failing buffer board, so I turned off the TV and tested them again. Oddly enough, the lower buffer has failed, the top one is currently working. I wanted to show that video. This is our board. That's the board that is supposed to be sent to the customer. And as you can see, it has normal top of the screen. It's working fine. The lower buffer has shorted, and this is how I know. I actually have probably shown that many times, but the way to go about it is, for those buffers, is to simply test resistance between VS and ground, sorry, not VS, the sustain output of the sustain board and the floating ground. On those buffers, it is the first and the last pin, and as you can see, there is a 5 ohm resistance between those. Usually when that happens, this is just the first and the last pin on the connector. And I'm going to get our own testing buffer board, with which I actually shot a video literally 30 minutes ago, and it is already on YouTube, so you can see it if it is there. A proper buffer board will give you something like 0.5, 0.6, it really depends on the meter, in one direction, and then this is how it is, and in the other direction it would be infinite. Notice I'm flipping the probes. Floating ground to sustain output. Come on. It works like a diode. It's infinite resistance here. So I'm going to send that video to the customer and let them decide what to do. This buffer looks good. It's reasonably well repaired. It's just that when we have so many available lower buffers, I don't know which IC has failed. I can find out. By the way to find out which IC has failed, has shorted on those buffers, is test for resistance between floating ground, which is all those many pins here, and sorry about that, and the individual pin outputs. This is the floating. Now you can see all those many shorted pins on this side, and between that and the outputs. Okay, here we have short here. So this points to this IC. All those tracks point to here. There is a shortage here. This is the bad IC. What probably has happened, and this is something that we've been saying over and over again, those are old ICs. This buffer has worked for a long time. At some point this has failed. This is the IC that was replaced. And imagine, I always make a parallel with a car tire. This buffer has driven for 50,000 miles and this has failed and was replaced, hopefully with a new one. Those remain on 50,000 and it's only a matter of time before they fail. It usually takes, another week or two. It usually, after the first one fails, it can take a good year, but it can be anywhere between something and a year. So that's how it is. Good luck now.